Sin 90 minus theta is equal to cos theta. Cos 90 minus theta is equal to sin theta. 1 by 2 constant, differentiation of x is 1. So the differentiated answer for this function is 1 by 2. What is required to find is to find dy by dz. What is dy by dz? dy by dx divided by dz by dx. X is nothing but x to the power of 3 by 2 whole square into d by dx of x to the power of 3 by 2. Hello dear students, welcome to this session. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous classes, I have taught regarding different types of differentiations, different methods of differentiations like function of a function, parametric equations, logarithmic function, explicit functions and implicit function, as well as second derivatives. Now in this session, I am going to take some miscellaneous problems based on all those methods. Let me discuss some miscellaneous problems based on all those methods. Now, let us come to the first problem. What are the problem here? If y is equal to log of log x to base 7, find dy by dx. What is given? Y is equal to log of log x to base 7, find dy by dx. Now, so far we have differentiated the function with respect to base e. You know, here d by dx of log x to base e is 1 over x, right? Logarithm of x to base e. But what is given? Logarithm of base 7 is given. So for this, let us change the base to e. We have one base change rule. Changing the base to e. Changing the base to e. We have one rule, logarithmic rule, that is log n to base a can also be written as log n to base e divided by log a to base e. This is called base change rule. This can be called it as, this is nothing but base change rule. This is base change rule in logarithms. Log n to base a, changing the base to e, we can write log n to base e divided by log a to base e. Same step I am going to apply here. Changing the base to e, I can write y is equal to log of log x to base e divided by, change this base log 7 to base e. Okay, apply logarithm for this new n, log n to base e. Again for this base, we are going to get it as log of log x to base e divided by log 7 to base e. Now differentiate this. Now differentiating with respect to x. dy by dx is equal to, you can apply u by v method formula, or very easiest step is log 7 to base e is a constant. I can remove log 7 to base e out and differentiate this. Now this is nothing but function of a function. Differentiation of log x is 1 over x, 1 over log x into d by dx of this inside function log x. This can be written as 1 over 7, 1 over log 7 to base e into 1 over log x into d by dx of log x is equal to 1 over x. So the differentiated answer is 1 over log 7 to base e into 1 over log x into d by dx of log x is 1 over x. This is the simplified answer, that is 1 over, you can also write this as 1 over log 7 to base e into x log x to base e. This is the simplified answer for this problem. Followed? So here, changing the base to e, log of log x to base e divided by logarithm of 7 to base e, differentiating with respect to x. Since logarithm of 7 to base e is a constant, constant is kept out, 1 over log 7 to base e is out, and differentiate the numerator. Differentiation of log x, let us assume this as x, function of a function, composite function. Differentiation of log x is 1 over x, instead of x it is log x, into d by dx of log x is 1 over x. So therefore this can be written as 1 over log 7 to base e into x log x is the differentiated answer for this. Hope you followed this. Very important problem. Now let us come to the next problem. Now what is the problem given? If y is equal to e to the power of secant square x plus 3 cos inverse x, find dy by dx. Now this is given. What is given? Y is equal to e to the power of secant square x plus 3 times cos inverse of x. Now differentiate this. differentiating with respect to x. What you will get? Dy by dx is equal to term by term differentiation e to the power of secant square x plus d by dx of 3 times cos inverse of x. Now this is equal to, since you know e to the power of dx, d by dx of e to the power of x is e raised to x itself. Instead of x it is secant square e to the power of secant square x into d by dx of secant square x, again function of a function, plus you know the derivative of tan inverse cos inverse x is minus 1 by root of 1 minus x square, standard formula it is. This is e to the power of secant square x into, again this is function of a function, d by dx of secant square x, f of x to the power of n. Use this formula, d by dx of f of x to the power of n is equal to n into f of x to the power of n minus 1 into f dash x. Derivative of this f of x is f dash x. Here n is equal to 2 secant x into d by dx of secant x is secant x into tan x minus, plus into minus, minus 3 divided by root of 1 minus x square, or this can also be written as, therefore dy by dx is equal to, what is the answer we are going to get is e to the power of secant square x into 2 secant x into secant x is 2 secant square x tan x minus 3 divided by root of 1 minus x square. This is the differentiated answer. So the derivative of this function is e to the power of secant square x into 2 secant square x tan x minus 3 divided by root of 1 minus square x 1 minus x square, and the root is the simplified answer for this. Hope you followed this. This is also very important for 3 marks. Now this is 2 marker question, very simple. See, what is the problem given? Y is equal to cos inverse sin x, find dy by dx. So this can be differentiated using 2 methods. The first method is, consider this as x, differentiation of cos inverse x is, first method I will teach, dy by dx, differentiating with respect to x, d by dx of cos inverse of sin x. Now you know differentiation of cos inverse, d by dx of cos inverse x is minus 1 by root of 1 minus x square. Here this is x minus 1 by root of 1 minus sin square x into d by dx of sin x. This is equal to minus 1 by root of 1 minus sin square is cos square x into differentiation of sin x is cos x. This is minus 1 divided by square and square root gets cancelled. What you will get? Cos x into cos x. Here cos and cos gets cancelled. This is equal to minus 1. So therefore dy by dx is equal to minus 1. Derivative of this function is minus 1. This is first method. Or you can also use another method to solve this problem. Now the same problem, y is equal to cos inverse. Let us convert sin to cos. So you know the formula for sin theta, sin 90 minus theta is equal to cos theta, cos 90 minus theta is equal to sin theta. Now let us convert sin to cos. Sin theta can also be written as cos 90 minus theta. This can be written as cos pi by 2 minus x. So what is cos pi by 2 minus x? It is sin x. So therefore this can be written as, since you know inverse trigonometric function, properties of inverse trigonometric function, cos inverse of cos x is equal to x. Cos inverse gets cancelled. Here this is equal to pi by 2 minus x. Now differentiate this. Differentiating with respect to x, what we will get? Dy by dx is equal to derivative of a pi by 2 constant 0 minus derivative of x is 1. This is equal to minus 1. This is the another method, second method. This is second method and this is first method. Any method you can use to solve this problem. One is direct straight differentiation. Another one is converting sin to cos. Sin theta is equal to cos 90 minus theta. Cos inverse of pi by 2 minus x is pi by 2 minus x. Differentiate this. Derivative of a constant 0. Derivative of x is 1. So the answer is 0 minus 1 is minus 1 is the simplified answer. Any method you can use to solve this problem. Followed. Now let us come to the next problem. What is the problem given? if f of x is equal to tan inverse of sin x divided by 1 plus cos x, find f dash of x. You know f dash of x is nothing but the derivative of the function. Now, convert this to the simplest form using trigonometrical identities or trigonometrical ratios. What is given? F of x is equal to tan inverse of sin x divided by 1 plus cos x. Now, using these formulas, tan inverse of, so we know the formulas for sin x using multiple angle, submultiple angle. Sin theta is also equal to 2 sin theta by 2 into cos theta by 2. This can be written as 2 sin x by 2 into cos x by 2. Now 1 plus cos x, for 1 plus cos x we have 1 plus cos x is equal to 2 cos square x by 2. Now make use of these two formulas. Why tan inverse of sin x, what is sin x? 2 sin x by 2 into cos x by 2 whole divided by 1 plus cos x is equal to 2 cos square x by 2. Now this 2 and 2 gets cancelled. One sin and one cos and cos in the numerator and denominator gets cancelled. What is left over in the numerator is tan inverse of sin x by 2 divided by 1 cos x by 2 in the denominator. So this is equal to tan inverse of sin by cos is tan x by 2. Okay. Now therefore y is equal to, this is y. Y is equal to tan inverse of tan is again x by 2. This can be written as of x. Differentiate now. Differentiating with respect to x. Now derivative dy by dx is equal to 1 by 2 constant. Differentiation of x is 1. So the differentiated answer for this function is 1 by 2. Followed. Very simple problem. See here. F of x is equal to tan inverse sin x divided by 1 plus cos x. So therefore tan inverse of sin x can be written as 2 sin x by 2 cos x by 2. 1 plus cos x is 2 cos square x by 2. 2 gets cancelled. 1 cos and cos gets cancelled. This is sin by cos is tan. Tan inverse of tan is equal to x by 2. This is nothing but f of x. So therefore the derivative of f of x is f dash x is also equal to dy by dx, that's equal to 1 by 2 because differentiation of x is 1. So f dash x is equal to 1 by 2. Suppose if we differentiate again, if they ask to find second derivative d square y by dx square or f double dash x, then differentiation of 1 by 2 constant is 0. That's it. Let us come to the next problem. F of x is equal to sin x to the power of sin x where 0 less than x less than 5. Find dy by dx or f dash x. This is again logarithmic differentiation. Now let us consider this as x, this f of x as y. Let me take it as y. Let y is equal to sin x to the power of sin x. Now taking log on both sides, taking log to base c on both sides. Therefore this can be written as log y to base c is equal to logarithm of sin x to the power of sin x. You know this logarithmic formula, logarithm of m to the power of n to base a is n log m to base a. This is log y to base a is equal to log m to the power of n is n log m sin x into log of sin x to base a. Now differentiate this, differentiating with respect to x on both sides. Differentiation of log y is 1 over y dy by dx is equal to, this can be differentiated using two product rule, two functions, product rule, UV method. First function sin x into, differentiation of log x is 1 over x, 1 over sin x into d by dx of sin x is cos x plus second function constant log of sin x into differentiation of sin x is again cos x. Now cancel the terms which gets cancelled. Here one sin x and sin x gets cancelled. So what is left over is only dy by dx is equal to transfer y to the right hand side. Y into cos x into 1 is cos x plus log of sin x into cos x. Log of sin x into cos x. Substitute the value of y. So this can also be written as f dash x. So f dash of x is equal to, what is y? Y is nothing but sin x to the power of sin x. Sin x to the power of sin x into cos x plus log of sin x into cos x. This is the differentiated answer. This is the required answer. See here. So UV method, first function sin x, differentiation of log sin x is 1 over sin x into d by dx of sin x is cos x plus log sin x as it is constant, d by dx of sin x is cos x. One sin and sin it gets cancelled. What is left over is cos x into 1 is cos x. Transfer this y to the right hand side. Dy by dx is equal to y into cos x plus log of sin x into cos x. So substitute the value of y. What is y? Sin x to the power of x. Remaining steps are same. But dy by dx can also be denoted as f dash x. So therefore f dash of x is equal to sin x to the power of sin x into cos x plus log sin x plus into cos x is the required answer. Hope you followed this. This is logarithmic differentiation. Now same, let us come to this. Differentiation of one function with respect to other function. So far we have differentiated with respect to x or with respect to y. Now here differentiate sin square x with respect to e to the power of cos x. Differentiate sin square x with respect to e to the power of cos x. This is nothing but same as that of the parametric equations. Now here let us consider, let y is equal to sin square x and call it as z is equal to e to the power of cos x, two functions. So y is a function of x, z is also a function of x here. Now what is to find? To find dy by dz, that's all. To find dy by dz. What is dy by dz? Dy by dz is dy by dx divided by dz by dx. That means just differentiate this with respect to x, again differentiate this with respect to x and substitute in this equation. Now differentiating with respect to x, dy by dx is equal to f of x to the power of n is n f of x to the power of n minus 2 sin x into differentiation of sin x is cos x. That's it. Come to this differentiating with respect to x, dz by dx is equal to d by dx of e to the power of x is e power cos x into differentiation of cos x is minus sin x. Now therefore dy by dx, this becomes dy by dz. Now therefore dy by dz is equal to dy by dx is 2 sin x cos x divided by dz by dx is e to the power of cos x into minus sin x. So cancel the term, one sin and sin x gets cancelled. Therefore dy by dz is equal to, just transfer this minus here. What is left in the numerator is 2 cos x divided by in the denominator e to the power of cos x. This is the required answer. So this is nothing but the same step we are going to use in parametric differentiations also. In parametric, what we are going to do differentiating with respect to the parameter theta or t, and we are going to divide dy by dx is equal to dy by d theta divided by dx by d theta, or dy by dx is equal to dy by dt divided by dx by dt. The same step with respect to x we are differentiating. So just what is given, y is equal to sin square x and z is equal to e to the power of cos x. What is required to find is to find dy by dz. What is dy by dz? Dy by dx divided by dz by dx. Now differentiate this with respect to x. Differentiation of sin in sin square x. This is f of x to the power of n is 2 sin x into differentiation of sin x is cos x. Again differentiation of e to the power of x is e to the power of x into d by dx of cos x is minus sin x. Dy by dz is equal to dy by dx divided by dz by dx, that is 2 sin x cos x by e power cos x into minus sin x. Sin and sin gets cancelled. What you will get? Minus 2 cos x divided by e to the power of cos x is the required answer for this. Okay, hope you are following. Now let us come to the next problem. Now what is the problem given? Y is equal to sin inverse of x root x, where x is in between 0 and 1, find dy by dx. This is also an important problem. So here this can be differentiated. Straight away you can differentiate. Consider this as x into x to the power of root as 1 by 2. Root of x is nothing but x to the power of 1 by 2, and simplify. Let me convert this first. X into root x. x into root x can be written as x to the power of 1 by 2. So this is nothing but x to the power of half. You know law of indices, a raised to m into a raised to n is a to the power of m plus n. A to the power of m into n is a to the power of m into a to the power of n is a to the power of m plus n. This can be written as 1 plus half x to the power of, take LCM, 2 is LCM, 2 ones are 2 plus 1 is 3 by 2. This is x to the power of 3 by 2. The given equation becomes y is equal to sine inverse of x root 1, x root x can also be written as sine inverse of x to the power of 3 by 2. Now differentiate this, differentiating with respect to x, differentiating with respect to x. Dy by dx is equal to d by dx of sine inverse of x to the power of 3 by 2. Since we know what is d by dx of sine inverse x, differentiation of sine inverse x is 1 by root of 1 minus x square. This can be written as 1 by root of 1 minus x square. X square is x to the power of 3 by 2 whole square into d by dx of this x to the power of 3 by 2 function of a function. Followed. See here, sine inverse x, instead of x it is x to the power of 3 by 2. Differentiation of sine inverse x is 1 by root of 1 minus x square. X is nothing but x to the power of 3 by 2 whole square into d by dx of x to the power of 3 by 2. Now here this can be written as 1 over square root of x to the power of 3 by 2 whole square, means this 2 and 2 gets cancelled. You will get x cube 1 minus x cube into differentiation of x to the power of 3 by 2, nx to the power of n minus 2, 3 by 2 x to the power of 3 by 2 minus 1, nx to the power of n minus 1. This is equal to 1 over root of 1 minus x cube into 3 by 2 whole to the power of x to the power of, take LCM, 2 ones are 2, this is nothing but 1 by 2. So 1 over root of 1 minus x cube into 3 by 2 x to the power of 1 by 2. If you want, you can stop here itself, or if you want further simplification, you can write it as, this is 1 over root of 1 minus x cube into 3 by 2 x to the power of 1 by 2 is nothing but root x, or this can also be written as 3 root x divided by 2 into root of 1 minus x cube is the differentiated answer. The simplified answer is 3 root x divided by 2 into root of 1 minus x cube is the simplified answer for this problem. Followed. See here, x root x can be written as x to the power of 3 by 2. Differentiation of sine inverse x is 1 by root of 1 minus x square, 1 minus x to the power of 3 by 2 whole square into d by dx of x to the power of 3 by 2. 2 gets cancelled, 1 minus x cube. Differentiation of x raised to 3 by 2 is 3 by 2 x to the power of 3 by 2 minus 1. This is 1 by root of 1 minus x cube into 3 by 2. Take LCM and simplify, you'll get 1 by 2. So 1 by 1 minus x cube under root, as it is 3 by 2 into x to the power of half can be written as root x, or if you want you can multiply 3 root x divided by 2 into root of 1 minus x cube is the simplified answer for this. Hope you followed this. Now this is very important problem for 5 marks. This is a 5 marker question. Sometimes you may expect this for 5 marks. Very important problem. This is the given equation. What is given? Given equation is x into root of 1 plus y into root of 1 plus x is equal to 0. Transfer this. X into root of 1 plus y is equal to minus y into root of 1 plus x. Just bring this to the right hand side, plus becomes minus. Squaring on both sides. If you square on both sides, squaring on both sides, this is x square into square root gets cancelled, 1 plus y. Again minus y square is plus y square. Again square root gets cancelled, you will get 1 plus x. Further simplify this. This is x square plus x square into y is x square y. 1 into y square is y square plus x into y square is xy square. Bring this to the left hand side. X square plus x square y minus y square minus xy square is equal to 0. Now just group the terms containing square terms. X square minus y square one group plus x square y minus xy square is equal to another group. Now this is one group and this is another group. Now you can remove the common. This can also be written as, first write down this as x plus y into x minus y. Simplify this, then remove the common factor. A square minus b square is equal to a plus b into a minus b. X square minus y square is equal to x plus y into x minus y. Plus here what is the common factor? Xy you can take it as common factor. So what is left here is x minus y is equal to 0. In these two, common factor is x minus y into x plus y plus xy is equal to 0. So x minus y is equal to 0 or x plus y plus xy is equal to 0. This implies x is equal to y, but x is not equal to y. Now consider this, x plus y plus xy is equal to 0. Using this, we can find the derivative. Okay. Now this is the simplified step. First simplify this. That is why it is very important problem. So what is given? X into root of 1 plus y into root of 1 plus x is equal to 0. Transfer this to the right hand side. X into root of 1 plus y is equal to minus of y into root of 1 plus x. Squaring on both sides. X square into the square root gets cancelled. Minus y square. Minus into minus plus, it is y square. Minus becomes plus. Y square into 1 plus x. Now multiply. X square into 1 is x square y. Y square into 1 is y square plus xy square. Just transfer to the left hand side. X square plus x square y minus y square minus xy square is equal to 0. Group the terms containing square. X square minus y square one group. X square y minus xy square another group. This is another group. Now this is how the form a square minus b square is a plus b into a minus b. X minus y into x plus y. Here you can remove xy common factor. Xy into x minus y. In these two, x minus y is the common factor. Take it out. X minus y out. What left? X plus y plus xy. Since x minus y is equal to 0 or x plus y plus xy is equal to 0. But x is not equal to y. And you can use this x plus y plus xy is equal to 0. Using this, simplify, you will get the required answer. Hope you followed this. I will rub this. I am going to solve this. From this, x plus y plus xy is equal to 0. Now make this as one group. Y, you can remove y common factor. 1 plus x is equal to transfer minus plus x becomes minus x, or y is equal to minus x by 1 plus x. Now differentiate this. Differentiating with respect to x on both sides. So dy by dx is equal to minus out d by dx of x by 1 plus x. This is of the form u by v, quotient rule. This can be written as denominator 1 plus x into differentiation of numerator x is 1 minus numerator x into differentiation of 1 is 0, again x is 1 whole divided by denominator square 1 plus x whole square. Simplify this. Minus as it is. If you simplify 1 plus x, again minus x whole divided by 1 plus x whole square. Minus x plus x gets cancelled. What you will get here? Minus 1 divided by 1 plus x whole square. That is the required answer. Minus 1 divided by 1 plus x whole square or x plus 1 whole square is one and the same. This is how we are going to simplify this. Here, consider the second part. X plus y plus xy is equal to 0. Y, if you remove y common factor, y into 1 plus x is equal to minus x divided by 1 plus x is the value of y. Differentiate now. Differentiating with respect to x, minus out. This is of the form u by v. Denominator into differentiation of numerator is 1 minus numerator into differentiation of denominator divided by denominator square. Multiply 1 plus x into 1 is 1 plus x minus x plus x minus x gets cancelled. Minus 1 divided by 1 plus x whole square. The required answer is minus 1 divided by 1 plus x whole square, or this can also be written as minus 1 divided by x plus 1 the whole square, which is the required answer. Okay, this is very important problem for 5 marks. Now let us come to the next problem. Now this is also an important problem. What is the problem? Y is equal to sine inverse of x plus sine inverse root of 1 minus x square, where x is in between 0 and 1. Prove that prove that y dash is equal to 0. The required answer for this is y dash is equal to 0. Now, see here, very simple problem here. This can be done in two methods. First method, I'll explain the first method. There are so many methods. The first method, y is equal to, what is given, sine inverse of x plus sine inverse of root of 1 minus x square. Since we know that sine inverse of root of 1 minus x square is also equal to cos inverse x root of 1 minus x square. Sine inverse of root of 1 minus x square is also equal to cos inverse x. So this can be written as sine inverse x as it is plus sine inverse root of 1 minus x square can be written as cos inverse x. This is equal to, since further we know one formula, sine inverse of x plus cos inverse of x is always equal to pi by 2. Properties of inverse trigonometric function, sine inverse x plus cos inverse x is equal to pi by 2. Differentiate this, differentiating with respect to x, dy by dx is equal to pi by 2 is constant, derivative of a constant is 0. So therefore y dash is equal to 0. That's it. This is the simple method. See here, sine inverse x plus sine inverse of root of 1 minus x square is also equal to cos inverse x. Sine inverse x plus cos inverse x is pi by 2. Derivative of pi by 2 is constant 0. That's it. So the required answer is 0. Or other method, if you want the second method. Second method is the straight away straight method. I'll rub this and go to the second method. Now come to the second method. Second method. Now direct differentiating. Differentiating with respect to x, dy by dx is equal to, differentiation of sine inverse x is 1 by root of 1 minus x square plus, again differentiation of sine inverse x is 1 by root of 1 minus x square. Instead of x square it is 1 minus x square whole square into d by dx of inside function 1 minus x square. Followed? See here, the first differentiation of sine inverse x is 1 by root of 1 minus x square plus differentiation of sine inverse x is again 1 by root of 1 minus x square. Instead of x it is root of 1 minus x square. So this is root of 1 minus x square into d by dx of root of 1 minus x square. Now this can be written as 1 by root of 1 minus x square as it is plus here 1 divided by square root of 1 minus, this square and square root gets cancelled, multiply by negative sign, minus 1 minus into minus plus x square into d by dx of root x is 1 over 2 root x. 1 over 2 root x. D by dx of root x, differentiation of root x is 1 over 2 root x. So differentiation of root x is 1 over 2 root x into d by dx of inside function 1 0, x square is 2x. This 2 and 2 gets cancelled. Here minus 1 and plus 1 gets cancelled. What is left over is 1 by root of 1 minus x square plus here 1 over square root of x square is x into, here what is left over is minus x divided by root of 1 minus x square. This x and x gets cancelled. What is left? 1 by 1 minus x square plus into minus minus 1 divided by root of 1 minus x square. Again these two gets cancelled, is equal to 0. So y dash is equal to 0. That's it. This is the second method. Any method you can use to solve this. So differentiate as ordinary differentiation. The standard formula is differentiation of sine inverse x is 1 by root of 1 minus x square. Here it is, instead of x it is root of 1 minus x square, 1 by root of 1 minus x square whole square under root into d by dx of inside function is root of 1 minus x square, multiply by negative sign, minus 1 plus 1 gets cancelled, you will get x, square root gets cancelled. Differentiation of root x is 1 over 2 root x into d by dx of 1 minus x square is minus 2x. 2 gets cancelled. Here 1 gets cancelled. Root of x square is x. X and x gets cancelled. 1 by root of 1 minus x square plus and minus gets cancelled. That's equal to 0, which is the required answer. Any method you can use to solve this problem. Okay. Hope you followed both the methods. Now let us come to the next problem. This is very important problem for 5 marks. Again, this is 5 mark question. What is given? If cos y is equal to x into cos of a plus y, prove that dy by dx is equal to cos square a plus y divided by sin a, where cos of a is not equal to plus or minus 1. Now this is a different problem. Now the given equation, what is the given equation? given equation is cos y is equal to x into cos of a plus y. Okay, bring this to the denominator. X is equal to cos y divided by cos of a plus y. See here, what is given? Cos y is equal to x into cos of a plus y. Just keep x here itself and transfer this to the denominator. Therefore, x is equal to cos y divided by cos of a plus y. Now, differentiate with respect to y. Now, so far we have differentiated with respect to x. Here we are differentiating with respect to y. This is the special problem. This is only the problem where we are going to differentiate with respect to y. Now, differentiating with respect to y, then what you will get? Dx by dy is equal to d by dy of this function cos y divided by cos of a plus y. Now, this is of the form u by v, numerator into denominator. Dx by dy is equal to d by dy of cos y divided by cos of a plus y. This is u by v. We are differentiating this function with respect to y. So, straight away I can put here denominator cos of a plus y into differentiation of cos y is minus sin y. There is no need to put dy by dx because we are differentiating y with respect to y. So, cos a plus y into differentiation of cos y is minus sin y minus numerator cos y into differentiation of denominator cos is again minus sin a plus y into differentiation of y is 1 divided by the denominator square cos of a plus y whole the square. This is the very important step. That's it. See here, denominator differentiation of cos y is minus sin y minus numerator into differentiation of cos of a plus y is minus sin of a plus y into a constant 0, differentiation of y is 1. Now, if you observe carefully, or this can also be written as dx by dy is equal to, here I can take this minus common factor here, minus of cos a plus y into sin y. Here this is minus into minus becomes plus. First consider this sin a plus y into cos y, okay, divided by, this can be written as cos of a plus y can also be written as cos square a plus y. This can also be written as dx by dy. Write down this positive term first, sin of a plus y into cos y minus cos of a plus y into sin y whole divided by, what is there in the denominator is cos square a plus y. Now, if you observe carefully, this dx by dy is equal to sin a cos b minus cos a sin b. Sin a cos b minus cos a sin b. Sin a cos b minus cos a sin b is nothing but sin a minus b formula. What is sin a minus b? Sin a minus b, sin a cos b minus cos a sin b. So, sin a cos b minus cos a sin b is sin a minus b. So, I can write this as sin a minus b. What is a? A plus y. What is b? Y divided by cos square a plus y. Now, minus y plus y gets cancelled. What is left in the numerator is sin a divided by cos square a plus y. Now, what is required to find is just reciprocate this. If you reciprocate, what you will get? Dy by dx is equal to cos square a plus y divided by sin a. This is the required answer you will get. Okay, that's it. So, therefore, dy by dx is equal to cos square a plus y divided by sin a. This is the required answer for this problem. See here, just differentiate with respect to y, then you will get dx by dy. In the numerator you will get sin a cos b minus cos a sin b form, that is sin a minus b, plus y minus y gets cancelled, sin a divided by cos square a plus y in the denominator you will get. So, then dy by dx is equal to reciprocate it, cos square a plus y divided by sin a. That is the required answer we are going to get. That's all regarding this problem. Hope you followed this. These type of problems are very, very important. These are all miscellaneous problems. That's all for the day. Let us meet with a different concept in the next class. Thank you very much.